Hello guys, welcome to my next lesson geared towards preparing us for the SAT exam. Now in this tutorial, I'm going to focus on exponential relationships. Now with exponential relationships, I've realized a very important aspect of it that a lot of people probably might find difficulty navigating through. So that's what I'm going to focus on in this video. So first of all, I'm going to talk about the general form of exponential relationships. Then, when I'm done with that, I would then talk about how we work with non-standard rate periods. Sometimes in a question, you'll be given an exponential relationship in a word problem, and then you'll be asked to give a model, that is an equation of an exponential relationship in a different rate period from that which was given in your problem. And that is one main difficulty most of the test takers face. So that's what we're going to focus on in this video. So first of all, the general form of an exponential relationship is, let's say you have y, okay, equals a b raised to the power x, okay, raised to the power x. Now your y here is, let's say, your final value in the end of an exponential increase of any value at all. Your a here will be your initial value. So this is your initial value. So a here would be our what? Initial value. Then this is your final value. Okay, so y will be your final. Then the b is the value by which your initial value is multiplied by. Okay, so in an exponential relationship, the initial value is multiplied by a certain value for every specific period of time. Okay, so let's say for every 10 years, your initial value increases like by 3 times. So your 3 will be your a. So this the value by which the initial value is increased by over a specific period of time. So let me write that here. Value by which your initial value is multiplied by in a specific interval. In a specific what? Interval. And then a specific interval, and your x will be the interval. Okay, your x here will be the interval or the time period within which your multiplication is happening. So I hope this is clear for now. Let's move to working with non-standard rates. Now this is very easy. So probably you are given you have an initial amount of money, let's say 1,000 Ghana cedis, and then so your initial is 1,000 Ghana cedis, and then for every year, okay, or let's say for every decade, your money doubles. Okay, so double, that means the number by which our initial value is multiplied by is 2. So that will be in the brackets here. And then because it's for every decade, here will be our decade. Okay, so decade will be here. So it will be 1 because we are working with decades. Okay, so because we are working with decades, and for every decade, so for every decade it doubles. So here will be 1 because we are working in decades. So probably you can put it y, okay, and put the time here. Let's say decades. Okay, so this is it. So you can use this to model a lot of relationships. You just have to know your initial value, then you know what your value is multiplied by for a particular interval at a period of time, and then you know the actual interval by which you are multiplying your initial value, and you are there. Then in some cases, you're actually given what you are multiplying by in a percentage. So let's say instead of this saying your value is multiplied by or is doubled for every decade, you'll be told that let's say the value increases by 50% for every 4 years. So y, okay, in 4 years, let's say represents 4 by f, will be equal to the initial value is 1000 as 10 to the power 3. Then you multiply it by, said it increases by 50%. And we all did in our videos on percentages. We know that if anything increases by 50%, you multiply it by 1 plus the 50%. So the 50% is 0.5. 1 plus 50% is 1.5. If you don't really understand how we did this, you can go and then watch my video on percentages where I discuss percentage increases or decreases. So you have 1.5, then you multiply it by your 1, because we're talking about 4 years and we said after 4 years. So this will be your relationship, how you model the relationship. So that's how this is very easy, straightforward. Just